Hello and welcome to this video on the volume of a cuboid. Now we know that area means how much space something takes up in 2D, and similarly in 3 dimensions the volume of something is how much space it takes up in 3 dimensions. So we might be curious to know how much space does this cuboid take up in 3D space. And one simple way we might do that is to count up the number of cubes that it takes up. So if we were counting the number of cubes here, what we could do is we could just concentrate on one layer. So if we take the bottom layer of cubes, the number of cubes we can see is it's a 4 by 3 grid. So 4 by 3 grid, that would be 12 cubes, wouldn't it? But then we have 2 layers of these cubes. So we know then that we do 4 times 3 and then times it by 2 because we've got those 2 layers of 12 cubes, which is 24 cubes. And that gives us a way that we can find the volume of a cuboid. We can see that we just times this length of 3 by the height of 2 by the breadth of 4. We just multiplied those numbers together and that gave us the number of cubes that we had. Now if the length of each cube was say 1 unit, then the volume of each of the cubes would be 1 unit cubed. If it's like 1 centimetre, it would be 1 centimetre cubed, the volume of each cube. And therefore the volume of this whole cuboid would be 24 centimetres cubed. So that is the volume of a cuboid. It's just the length times by the height times by the breadth, in any order, it doesn't matter what order you times those numbers in. Now let's use that to solve a few problems. So we've got this first one here. We've got a width of 6, a height of 5 and a breadth of 3 centimetres. So the volume is just going to be 5 times 6 times 3, which is equal to 90, and the unit would be centimetres cubed. So a unit with volume is always going to be something cubed. It could be centimetres cubed, it could be metres cubed, etc. What about the second question? A cereal variety pack is packed with smaller boxes, so we can fit a number of those smaller boxes within the large box. How many of those cereal boxes can you fit within the variety pack? Now there's 2 ways of doing this. One way is that we could find the volume of the variety pack and the volume of each individual cereal box, and we can see how many times that goes into that. So we would just divide the 2 numbers, the 2 volumes. So if we did that, the volume of the whole variety pack would be 40 times 20 times 9. We get 7,200 centimetres cubed, and the volume of each individual box would be 5 times 4 times 3, and that would be 60 centimetres cubed. And then the number of boxes we could fit in that variety pack would just be 7,200 divided by 60, and that gives us 120 boxes. That's quite a large variety pack, isn't it? The other way we could do it is that we could see, for example, how many times that 4 goes into 20, because you can see how many times you can fit a box along the variety pack, because if this whole thing is 20 centimetres and each box is 4 centimetres long, we can see that we can fit 5 boxes along because 4 goes into 20 5 times. So it goes across 5 times. And then you might see how many times it can go up. So how many times does 5 centimetres, the height there, go into 40? Well, we could see that we've kind of got 8 boxes going up because 5 goes into 40 8 times. And we said that was 5 boxes across. And then also we can see how many boxes deep we can go. So how many times does 3 centimetres go into 9 centimetres? We can fit 3 boxes deep like that. And then we just need to times 8 and 5 and 3. So if we did 8 times 5 times 3, that would be, again, 120 boxes. So that's another way you could do it. And particularly if you didn't have a calculator, then this method here is probably easier than this method here, where we're dealing with much larger numbers. What about this next problem here? We've got 2 cuboids here, and they have the same volume, and we want to determine this length x here. Well, the volume of this cuboid here is just going to be 20 times 12 times 4, so 20 times 12 times 4. And that's got to be the same volume, i.e. equal to the volume of this box here, which is going to be 8 times 8 times x. So if we write that, 8 times 8 times x. Now let's just simplify each side. 20 times 12 times 4 is just 960. And 8 times 8 is 64, so it's 64 times x. We can just write 64x. Now x is being multiplied by 64. We want to get rid of that 64, so we divide both sides by 64, and that gives us 15. So x is equal to 15, and it's in centimetres. And then finally, we've got this question here. A container is filled to 30% of its capacity with water. How many litres of water are there? Well, let's find the volume of the container first. The volume of the container is going to be equal to 30 times 12 times 10, and that is 3,600 centimetres cubed. And it says that 30% of it is filled with water. So we just need to find 30% of 3,600. We could find 10% of 3,600. That would just be a tenth of it, so that would be 360 centimetres cubed. And therefore 30% would be 3 times greater, which is 1,080. So I just times that value by 3. So that is the volume of water, and we want that in litres. Now, you need to know that 1 litre is equal to 1,000 centimetres cubed. You might also know that 1 litre is equal to 1,000 millilitres. So that means a milliliter is the same as a centimetre cubed. Now notice, to get from centimetres cubed to litres, we can just divide by 1,000. 1,000 divided by 1,000 is 1. And therefore, if we've got this value here, 1,080 centimetres cubed, we can just divide it by 1,000 to get it in litres. So 1,080 divided by 1,000, and that will be 1.08 litres.